So on page 21, again, we're going to continue talking about factoring, but I want to start with a little sort of warm-up intro problem here. I've given you a quadratic function in vertex form. I want you to take a minute and jot down everything that you can tell me about this function. Okay? Anything that you can tell me about what the graph would look like for this function. We've got vertex form. So how about we identify the vertex? Where's the vertex for this parabola? Mm-hmm. 1, -8. We have vertex form, so we can pick out the vertex. Our lead coefficient, our a value, also gives us some important information about the graph of our function. Since it's positive, what does that tell me about my parabola? Since it's positive, it's gonna open up. If it were negative, it would open down, but since it's positive, it will open up. And then since it's not 1, since I've got 2 there, that's gonna alter the shape of my graph. How's it gonna alter the shape of my graph? Other way. Stretch it, yeah. Number bigger than 1 is gonna stretch us out. A number less than 1 would sort of smash us down, compress us. But since that's bigger than 1, this is gonna stretch for graph. So just with vertex form, what we've got here, this is what we can tell about our function. Now, if we changed it to some other forms, if we changed it to standard form or intercept form, then we would get some more information. But just based on vertex form, here's what we can say. Okay, good little refresher, good little review of some of the graphing information that we've talked about. As we know, each of our functions gives us some important information. What we're going to continue to work on today is that intercept form. That form that gives us those x-intercepts. But what we're going to see today is that we've got, instead of just x squared, we're going to have a number in front of that x squared. We're going to have a lead coefficient that's not 1. If I hop back to our problems we worked on yesterday or the day before, in every problem we've looked at so far, it's just x squared. So our lead coefficient would just be 1 for all of these. So what we're going to see today, our problem for that lead coefficient is not 1. So what do we do if that lead coefficient is something else? And we're trying to write our function in that intercept or that factored form. So when that a value is not 1, the first thing I want to look to see is that a value a GCF or a greatest common factor for every term in my function? Okay. Could I evenly divide every term in my function by that value of a? So if I look at example 1, our a value is 2, b is -14, and c is 24. All even numbers, yeah? That means that all of these numbers could be evenly divided by 2. So what I'm going to do is go ahead and take this lead coefficient and divide it out or factor it out of my quadratic here. So I'm going to pull that 2 out. I'm factoring it out, which means I'm going to divide each term by that 2. So 2x squared divided by 2 would leave me with just x squared. -14x divided by 2 would leave me with -7x. And 24 divided by 2 would leave me with 12. Now I'm not getting rid of the 2. It's still there. And if I were to distribute it back, I would get the problem I had originally. My goal here is that I'm trying to make this part easier to factor. And so if we look at that 2 factored out, that GCF, greatest common factor, pulled out, now this is just like what we worked on Monday and yesterday. Okay, so this is back to a factoring problem that we worked on last time. So I want factors of C that add to B. So I need factors of 12 that add to -7. So what would multiply to give me 12, but add to give me -7? Multiply to give me 12. -3 times -4, perfect. So this part here would become x minus 3 times x minus 4. Don't forget to drop down that 2. And that would be our factored form. Now, remember, we can always check our work by distributing. And we had a problem that looked like this from yesterday. We were given that intercept form, that factored form, and we were asked to change it to standard form. So if I put back in my notes that we looked at yesterday, right, the second example we looked at yesterday was something really similar to this. I had that A value, that lead coefficient in front, and then 2 factors, and we multiplied everything together. We distributed everything together. So remember, I can always check my work by distributing. So I'm going to do that here really quickly. So I'm going to start by multiplying those factors with x together first. That would get me x squared minus 4x minus 3x plus 12. And then I still need to multiply that 2. Again, this is exactly like the second example we did yesterday. So that would give me 2x squared minus 8x minus 6x plus 24. When we combine our like terms, we have 2x squared minus 14x plus 24. And notice that's the same as our original problem. I can always check my factoring by distributing it back out. Since I got the same thing as my original problem, that means I factored correctly. So this is my factored form, or my intercept form. And then we're going to identify a couple of our key features here. Our y-intercept we get from standard form. Remember, it's C at the end of standard form, that constant term. So our y-intercept for this function is 24. And then our x-intercepts come from factored form. So that would be +3 and +4. And now, as a little more graphing review, especially as we get towards the end of our unit, based on that lead coefficient, what do I know about the shape of this graph? Bless you. Which way is this thing going to open? Up or down? Opens up. And then how's that 2 going to change this? Yeah, just like here, it's going to be stretched. So we're going to open up and be kind of stretched, a little taller, a little skinnier than normal. Questions for me on number 1? Okay, let's take a look at number 2. Same idea here. I have this A value, this lead coefficient of -3. I want to first look and see, could I actually evenly divide all of the other numbers by -3? So could I take 3 and divide it by -3? Yeah. Could I take 18 and divide it evenly by -3? Yeah. So -3 is again going to be a GCF, or a greatest common factor, that we can factor out or divide out of the rest of our problem. So when I divide out -3, -3x squared divided by -3 would just give me x squared. 3x divided by -3 would be -1x. So 3 divided by -3 would be -1. And then 18 divided divided by -3 would give us -6. So we had some sign changes in here. That's okay. I don't care if the sign changes. I just care if it's not going to divide evenly. So if I were to divide and it gave me a fraction or a decimal, that would be a problem, but the sign changes are fine. Now, just like in example 1, the stuff I've got left here inside of parentheses is something I can factor the same way we did the last 2 days. So I want factors of C, factors of -6, that add to B, add to -1. Factors of 6 that add to -1. -3 times +2. Multiply to give me -6. If I add them, I would get -1. So this would be x minus 3 times x plus 2. And then don't forget that -3 inside. Get that GCF we pulled out. So there's my factored form. Our y-intercept comes from standard form. It's that c value, that constant term at the end of our function. So our y-intercept for this parabola would be 18. Our x-intercepts, remember, come from intercept or factored form. So our x-intercepts would be +3 and -2. And then I want to know about our general shape here. So our lead coefficient this time was -3. Which way will this thing open? Negative means it's going to open down. And then what's the 3 going to do to it? Still stretch it. Yeah, stretch it a little more than our 2's did in the last couple of examples. So really narrow opening down parabola here. Questions for me on example 2? Okay. So kind of our best case scenario is if that lead coefficient can evenly divide all the terms and I just factor it out. And then what's left over, we factor just like we did the last couple of days. That's not going to be the case for every problem that we have. So if we turn to page 22, what we're going to see here are problems where that lead coefficient isn't a GCF, isn't a greatest common factor for the rest of my terms. So if we look at example 3 on the top of page 22, my A value, my lead coefficient is 3. And then I've got -16 and -12. -12 I could divide by 3, but -16 doesn't divide evenly by 3. So that means we can't use the same strategy we used on the last couple problems because -16 is not divisible by 3. If I try to divide it by 3, I'm going to get a fraction or a decimal. And that's not what we want. So instead, we have to take another approach here. I'm not going to be able to pull this 3 in front. It's going to have to stay stuck in one of my factors. Now, the nice thing about 3 is that it's prime, right? 3 is just 1 times 3. That's it. It doesn't have any other factors, just 1 in itself. So that means as I set this problem up, I know I have to have one factor that starts with a 3x and one factor that starts with a 1x. The tricky part from here is going to be filling in the ends of those factors. So we're still going to look for factors of -12. And for this problem, I'm going to go ahead and make that whole factor list like we did a few times over the last couple of days. So -12 could be 1 times -12, or -1 times 12, 2 times 6, 2 times -6, or -2 times 6, 3 times -4, or -3 times 4. My next factor would be 4, but I've already got those listed. So that's my whole list. Now, would any of these factor pairs add to -16? No. None of these add to negative 16. Okay? What I'm going to look for is not factors of negative 12 that add to negative 16 this time, because I know that when I distribute, one of these factors is going to be multiplied by 3x instead of just x. I've got sort of this extra layer here that I need to consider. So out of my list of factors, I'm going to pick two, right? I'm going to pick a pair, whichever pair that ends up being. I'm going to pick a pair of factors here so that when I multiply one of them by 3 and then add them together, I get negative 16. Does that difference make sense from yesterday? Okay, one of these numbers I'll multiply by 3 before I add them together. So the tricky part is figuring out which numbers I want. Which one's going to get multiplied by 3 out of the pairs that I have listed. For today's work, you might have to do some guessing and checking, and that's okay. It's okay to try something and then it not work. Then try something else. Does anyone have a thought on what they would like to try first? A hunch on something that might work? Or even if you don't have a hunch on, I think this might work, pick something and let's try it. Cody? Negative 2 and 6, you want to put these out? Okay, so any strong preference on if the negative 2 goes here or here? You want, we're switching it up. Okay, 2 and negative 6. And I want you guys to notice I switched the pencil here. I'm anticipating that at some point today, I'm going to try something that won't work. That's okay. So I'm using a pencil. So if it doesn't work, I can erase it. So 2 and negative 6. Any strong feelings on if the 2 should go here or here? Two should go with the 1x. So plus 2 and then minus 6. Now here's how we check this. Distribute. So this would give me 3x squared plus 6x minus 6x minus 12. The first term and the last term look great. Let's combine our x terms in the middle. 6x minus 6x would be 0x. These are not the same. So I know that particular combination, this ordering that I have isn't right. Let's try swapping. Let's try negative 6 here and positive 2 here. Is that what I just wrote? This is what we just did, right? Let's try actually swapping them. So plus 2 here and minus 6 here. There, does that look better? Okay, now let's distribute again. So I know this wasn't right. 3x times 1x would be 3x squared minus 18x plus 2x minus 12. Again, x squared term looks good, constant looks good. We got to check the middle. 18x plus 2x would be negative 16x. There we go. That's what we wanted. So our factored form would be 3x plus 2 times x minus 6. I had a little guessing and checking to do here, right? I tried something, I checked it, it didn't work, I tried something else. That's going to be kind of our theme for today. Question. The 1, the 1x. So the only factors of 3 are 3 and 1, right? Because 3 is prime. So I know for my x terms, there's going to have a 3x and a 1x. So you could have swapped their places. This is my own just sort of personal quirk. I like the bigger coefficient of x to be first. It doesn't have to be that way. So if I had swapped the order, then it would be 1x minus 6 and 3x plus 2 over here. that make sense? Okay. It's nice if that lead coefficient is prime, because then I can kind of lock in those numbers. That's something I know for sure. I have to have a 3x and I have to have a 1x. Or the next one we're going to see it's 2x squared. 2 is also prime. So I know it's going to be a 2x and an x or a 1x. And then we just have to play around with the factors of that second number. Did that answer your question?
Yeah.
Okay. Any other questions on example 3? Okay. So let's take a look at example 4. Same idea. Okay. Again, nice thing here is that our lead coefficient is prime. It's not a GCF because 3 and negative 9 cannot be evenly divided by 2. So I can't factor it out like we did those first two problems. Okay. But since this is prime, I know I'm going to have a 2x and a 1x, or just an x. Since it's prime, it's got to be 2 and 1. So then the goal is to figure out how do these factors end. So I'm going to look at factors of C, so factors of negative 9. And for problems like this, I like to make the whole factor list. So this could be 1 times negative 9, or negative 1 times 9, or positive 3 times negative. Those are all my factors of negative 9. For problems like this, I like to have the whole factor list because it gives me all my options for what I have to choose from. So I'm going to switch back to my pencil so we can do a little experimenting. Anybody have some thoughts on what they would like to try first? Remember, I'm wanting to get to positive 3x. Try the 3 and the negative 3. Which one do you want to put there? The positive one in the first factor and the negative one in the second? Okay, now let's give this a shot. 2x times x would be 2x squared minus 6x plus 3x minus 9. First term and last term look good. When I combine my x terms in the middle, I would get negative 3x. We want positive 3. How about we swap them? So let's make this one negative and let's make this one positive. Now let's try it again. 2x times x would be 2x squared, and then plus 6x minus 3x minus 9. Again, first term and last term look good. They match my original problem. Let's combine our like terms in the middle. 6x minus 3x would be 3x. Positive 3x is what we want. So this is our factored form. So 2x minus 3 times x plus 3. Questions on example 4? Now, as we keep working through these problems, if all you are writing on your paper is that final factored form, you're missing all the work that we've done on this one, okay? And when we have our test next week and you go look back through your notes to work on your study guide and prepare for our test, if you don't have this work here, right? The stuff that we tried that didn't work, that's important, okay? That's how we got to this, is we tried some stuff and it didn't work. If all we write down on our paper is that final correct answer, then we've missed like all of the steps that we tried in between. And I don't want you guys to think that we just came up with these out of nowhere and we just looked at our paper and knew that that's what it was, because we didn't. That's not what happened here, right? In example 3 and example 4, we tried some stuff. It didn't work, so we tried some more stuff, okay? It's okay to be wrong. It's okay to do stuff wrong before you find the right answer. That's important, okay? It's an important step of the process. Okay, let's take a look at example 5. Our least coefficient here is 9. I could evenly divide it out of my x term, but not out of my c. So we're in the same boat we were in before. Now there is a little difference here. This time my lead coefficient is not prime, right? 9 could be 9 times 1 or 3 times 3. So I don't automatically know what's going to go at the front of each factor this time. My c value, though, is prime. So I do know what's going to go with the back. So I know one of these factors has to end in 2 and the other has to end in 1. You could swap this order if you wanted to. Mm-hmm. So you're saying since the factors of 2, if I add those, I get 3, and I want 9, that you're saying we should use 3 times 3? Right, it's take your best guess, right? It's take your best educated guess. So you threw out 3 times 3. Let's try it in here. Okay. The worst thing that happens is it's not 3 times 3, and we try a 9 and 1 combination. So I also know that I'm going to have x here. So I'm going to go ahead and fill in the x's. And then the parts where we're guessing, I'm going to switch back to my pencil. So Cody said, I think we should try 3 times 3. I've got a hunch that it's 3 and 3. So let's try 3 and 3. See if it works. So 3x times 3x would be 9x squared. 3x times 1 would be plus 3x. 2 times 3x would be plus 6x. And then 2 times 1 is 2. My first term looks good. My constant term looks good. When we combine our x's in the middle, we get 9x. That's what we wanted. We got it on the first try on this one. If we didn't get it on the first try, what would we have done? Try something else, right? Questions on 5. Okay, let's try 6. Our lead coefficient, our A value for 6, is 2. Example 6 has something in common with those first couple of examples we looked at. Minus 20. There was a typo on your paper, so I fixed it in your packets. Okay. This has something in common with those first 2 factoring problems we looked at today. Yeah, my other terms are divisible by 2. So we get to pull the 2 out as the GCF. So I'm going to factor that 2 out. That would leave me with x squared, since 2x squared divided by 2 is x squared. And then 18x divided by 2 would give me 9x. Negative 20 divided by 2 would give me negative 10. I think these are the easier problems when you could pull that lead coefficient out as a GCF, because then the stuff that you're left with, we can factor like we did the first couple of days. So I want for this problem, factors of negative 10 that add to 9. Factors of negative 10 add to 9. Negative 1 times 10, perfect. So this guy would be x minus 1 times x plus 10. And then don't forget that 2, that's important. And there's my factored form. I want you guys now to try problems 7 and 8. Give these a try without me. Try 7 and 8. Remember, it's okay to guess and check here. Try something. If it doesn't work, try something else. Okay, that's part of the process. That's good. I mean, you guys are trying. That's the first step on this. Pick something to try. For you guys who are on Zoom, I made the comment a minute ago that I'm seeing a lot of people have to flip their pencils over to erase things. And I said that that's good. I like to see that because that means that you tried something. It didn't work, but you tried it, recognized that wasn't right, and then erased it to try something else. That's the whole process here is try something, see if it works. Okay. If it doesn't, try something else. For example 7, our lead coefficient is not prime. So to get 6, I could have had 6 times 1 or 3 times 2. To get -2, our C value, That could have been -1 times +2 or +1 times -2. So I have my list of options for what to put in each space. So I know I'm going to have something x and then something times something x plus or minus something, right? I know the x's go in there, but these other numbers are going to be a guess. So somebody give me a guess. Let's pick something to try. Let's start with 6 and 1. That gives us a place to start from. Let's start with 6 and 1. So let's say it's 6x and 1x. And then let's pick some factors here. Let's try our -1 and 2. I'm just picking something to try. I don't have any sort of inclination on or any good guess on which pairs I want. I'm just going to pick something. So let's try -1 and +2. The worst thing that happens is this doesn't work and I try something else. So if I distribute here, I would get 6x squared plus 12x minus 1x minus 2. When I combine my middle terms here, I would get 11x. I want -1x. This one didn't work. Before I completely scrap all of these, I'm going to try switching those numbers. So 6x times x would give me 6x squared minus 6x plus 2x minus 2. When I combine my middle ones this time, I get minus 4x. That one didn't work either. Do you guys want to switch these numbers, the end numbers, or the beginning numbers? You want to switch the beginning ones? You want to try 3 and 2 instead? Okay. So we tried 6 and 1 with 1 and 2. That wasn't it. So let's now try 3x and 2x. Let's see if that works. So I tried a combination. It didn't work the first time, so I switched one of those numbers. You don't need to switch them both because remember the idea is that we're distributing to different things the next time. So we switched the first numbers, switched them out to another option. When I distribute now, 3x times 2x gives me 6x squared minus 3x plus 4x minus 2. When I combine my middle terms this time, I would get plus 1x. I want -1x. How about we try switching the back numbers again? Switch them back. So plus 2 minus 1. Let's see if this works. 3x times 2x is 6x squared plus 6x minus 2x minus 2. That gave me positive 4. That didn't work either. How about we try our other option here, this time where the 2 is negative. That's the last version that we did, I think. Did you say +1 or -1? Okay. Okay, -2. So we're trying this option now. And then +1. Let's try this guy. 3x times 2x would be 6x squared. Oops, we did that one. Plus 3x minus 4x is looking promising. Minus 2. Combine our middle terms and we get minus 1x. That's what we wanted. Took us a lot of tries here, right? That's okay. That's okay. This is our factored form here. The more, like I said the other day, the more you practice these, the easier it will get because you'll start to develop some number sets. Well, I know if I do 3 and -2, if I multiplied those, I would get -6. And then 2 and 1 would give me 2. That's not going to add to -1, so I don't want that one. As you guys work on these more, you'll start to develop that number sense more. So if you flip the first one and flip the second one, that's the same as what you originally had. You can completely reorder your factors. So if you wanted to give me 2x plus 1 times 3x minus 2, this would distribute the same way. You would get the same thing that we got here. So that's why, like here, I switched the first two and I switched the second two. It's the same thing. Just like the other day when we talked about how if I switch this factor and this factor, I put them in the other order, I distribute to get the same thing. Same idea here. Okay, one more. Let's try number 8 really quickly. I want to talk a little bit more about that number sense idea here as we look at example 8. So I've got 4, which is not prime, and negative 25, which is also not prime. This is probably the hardest problem on this paper because I've got so many things that are not prime. So for 4, that could be 4 times 1 or 2 times 2. For negative 25, that could be 1 times negative 25, negative 1 times 25, or 5 times negative 5. That's a lot of options to consider, right? Even more than our last problem. So I want to think for just a minute about my number sense. And this is something that we'll work on the more of these that we do. If I take my 4 and 1 option and a 1 and 25 option, 4 times 1 would give me 4. 1 times negative 25 would give me negative 25. I want to get negative 15 here. 4 minus 25 is not going to give me negative 15. If I swap the order and did 4 times negative 25, now I'm at negative 100. That's way, way, way too low. So I know this combined with this is not what I want. If I did the 4 and 1 option with my negative 1 and positive 25, I could have negative 4 plus 25, which isn't going to give me negative 15. Or if I did the 4 times 25, that's 100 minus 1, which is also way off of what I need. The last option as I'm going through these, so I'm doing the same thing we do if we distributed, but I'm trying to do it sort of shorthand, right? I'm working on that number sense. If I did 4 times 5, that's 20, and then 1 times negative 5 would be minus 5. 20 minus 5 is 15. That's not quite what I want, so let's swap them. 4 times negative 5 would be negative 20. 1 times 5 would be 5. There's what I want, okay? So my factor form here, I want 4x and 1x. I want 4 to multiply by negative 5 to get negative 20. So I've got to put the negative 5 at the back of the second one so that they multiply together. My positive 5 needs to go here so it can multiply by the 1. As you do this more, you'll be able to get these a little bit faster, okay? Homework for today, pages 23 and 24, no Zoom for tomorrow. We're gonna do some in-class practice with a quick check. If it's your remote day, you'll have a Delta Math assignment. I'll see you guys next time. Okay, for you guys on Zoom, that was our bell. So I will see you tomorrow.